Hey guys, it's Miss Johnson and I'm here to bring you our video for today. Today we are talking about solving systems of equations by elimination. So we've talked about solving systems by graphing, we've talked about solving systems using substitution, and now we're going to talk about solving systems using elimination. This is another algebraic method, so we are not going to be graphing equations today, although graphing is always a way that you can check your answer if you're interested, but we're going to be using another algebraic method. So when we are trying to solve a system, we have two equations that each have two variables, two equations with two variables. And you can't solve two equations with two variables. You have to only have one equation with one variable in order to solve. So we need to get rid of one of those variables. Now, when we were substituting, we would take a phrase and insert it for another variable so that we would eliminate that one variable. Now we're going to be doing elimination, okay? Now, here's where elimination is best used. You're going to have to write kind of small. The box on your notes page is kind of small, so just to warn you. It's best to use when your equations are in standard form. Standard form, meaning you have ax plus by is equal to c. Okay, best to use when your equations are in standard form. So you've got those x's and y's together on one side and the constant alone on the other. That's when we're going to use elimination. Now, if we have a system that's set up like that, here's our steps. We need to take the two equations and add them together. We're going to combine the two equations. One of the variables will hopefully cancel out. Okay, one of the variables should cancel. After that, we're going to solve for the variable that's left. So there will be one variable left. We have to solve that equation. And then the last step is the same as substitution. We're going to put that back into either one of the equations and solve for the missing variable. Okay, so 3 steps there. Remember, you can always pause the video at some point if you're still writing or need to take a minute to finish writing all this down. So let's go ahead and look at some examples. I'm going to look at number 1. It says x plus 2y equals 10 and negative x minus y is equal to negative 6. So now what I want to look at is the fact that well, first of all, I have my x's lined up, I have my y terms lined up, and I have my constants lined up on the other side of the equal sign. This is that standard form, ax plus by is equal to c. So both equations are in standard form. X is lined up, y is lined up, constants lined up on the other side. Now I'm ready to add these together. So when I add these together, x plus negative x cancels out because 1 minus 1 is 0. And then that's where the elimination piece is. My x term is now gone. So now when I put the other two terms together, 2y minus y is just y. That's like 2 minus 1. And then 10 minus 6 is 4, or 10 plus negative 6 is 4. So I'm left with y equals 4. Well, if this were an equation that had more stuff in it and I had to solve for y, I would do that. But y is already solved here. So I've got one variable down. Yay. Now I need to take that 4 and I need to plug it back into either one of the equations in the top. If I do the top equation, x plus 2 times 4 equals 10. All I did was take the 4 and plug it in for the y right there. So then I have x plus 8 is equal to 10, subtract the 8, and x is equal to 2. So I now have x is 2 and y is 4. Be careful how you write this solution. I still have some people that are writing this as yx. Equations always go x comma y. Okay, or points, I should say. Points always go x comma y. So if I was going to write this as a solution, I would have 2 comma 4. X is 2, y is 4. All right, let's take a look at number 2. In number 2, again, I want to check to make sure that they're lined up. I have my x terms together, I have my y terms together, and I have my constants together on the other side of the equal sign. Here's my equal signs. Okay, those have to be lined up as well, by the way. X terms, y terms, equal signs, constant. We're good. So now I'm going to add these two together. When I add these two, 2x minus 3x is negative x. So that purple's kind of hard to see. Negative x. The y terms, positive y and negative y, cancel out. They go away. Then on the other side of the equal sign, I have 4 minus 8, or in other words, 4 plus negative 8, which is negative 4. divide by the negative 1, because I have a negative in front of that x there, so that cancels that. I have x is equal to positive 4. So now I need to take that and I need to plug it back in. So that's my first variable. I'm done. I've got my first variable. So I plug that back into either one of the equations. 2 times x plus y equals 4. I'm going to plug my 4 right in for the x term. 2 times 4 plus y is equal to 4. That's 8 plus y is equal to 4. Then subtract the 8, and I get y is equal to negative 4. So if I write this out as an ordered pair as a solution, this is my x term, that's my y term, I have 4 comma negative 4. That is the solution to the system. Let's try the next one together. We have negative 2x and plus 3y equals negative 11 and 2x plus 2y equals 6. So again, I want to check to make sure. I've got x terms lined up, y terms lined up, equal signs lined up, constants lined up, everything's ready to go. So I'm going to add these two together. So now I have negative 2x and 2x. Negative 2x plus 2x goes away. Negative 2 and 2 make 0, so those are gone. Then I have 3y plus 2y, that's 5y. And negative 11 plus 6, negative 11 plus 6 is negative 5. So 5y equals negative 5. I need to solve for the y. Divide both sides by 5 and end up with y is equal to negative 1. Then plugging that back in, I'm going to use the bottom equation just so I get rid of that negative that's in front. It doesn't really matter, but just to help me out a little bit, I have 2x plus 2 times negative 1 equals 6. That's 2x minus 2, because 2 times negative 1 is negative 2, is equal to 6. Add the 2, and I have 2x equals 8, divided by 2, and x equals 4. So I've got x equals 4, y equals negative 1, and I write those out as an ordered pair, 4 comma negative 1. All right, I'm going to skip number 4 for now, and I'm going to move on to number 5. We'll come back to number 4 and do that in class together. Let's take a look at number 5. In number 5, we have x minus y is equal to 9, and negative 7x minus y is equal to negative 7. Now, my x terms are lined up, my y terms lined up, equal signs lined up, constants lined up, so I'm good with that. But if I try to add this together right here, take a look at what happens. X minus 7x is negative 6x. Negative y minus y is negative 2y. And then 9 minus 7 is 2. Now I have a problem here. My y term didn't drop out like I expected it to because 1 is not positive. I have 2 negative y terms here. So what I need to do is I need to account for that, and I need to switch each term in the top to make it its negative. Essentially, it's like multiplying the whole thing by a negative 1. You're going to distribute a negative 1 all the way throughout and actually change that first equation so that everything behind it is its opposite. So let me rewrite this system for you, and let's take a look at what it looks like. So the top equation now looks like negative x plus y equals negative 9. The bottom equation I'm going to leave the same, negative 7x minus y equals negative 7, because now take a look at it. Now when I add these together, I have positive y, negative y, those cancel out. Then negative x minus 7x is negative 8x, and negative 9 minus 7 is negative 16. They're both negative there, so negative 16. Now when I divide by the negative 8, solving for x, I get x is equal to positive 2, and I can plug that 2 back into either one of the equations. If I use the original top one, I'd have 2 minus y equals 9. That is, subtract the 2 there, negative y is equal to 7, and divide by the negative 1, and I get y is equal to negative 7. So the solution that I get here is 2 comma negative 7. And by the way, you can always check your solution that you find. If I take 2 and negative 7 and plug it back in for x and y, I should get 9. If I plug it back in for x and y in the bottom equation, I should get negative 7. So you can always go through and do that if you're interested to make sure that you have the right thing. All right, we're going to go ahead and stop the video at this point. So please hop back to Schoology and take that quiz when you get a chance, and we'll finish up the notes together in class. Have a great day.